Welcome, guys. Hope things are going well there. The recovery on this leg of mine will bring me back on Thursday. So that means I won't see you today, tomorrow, or Wednesday. I'll be back on Friday for you. And I guess I need you to be as patient as well as hardworking as I can while I'm out. It takes me a while to put these things together. And so please pay attention and please keep moving forward. I want to go through the questions that you were assigned and talk about them. The first group of questions were about a reference angle, and what you were to have learned about a reference angle is it's between 0 and 90, and it is always an angle formed with the x-axis. So in the very first question, they give you an angle of 22, and that is between 0 and 90, and it is formed with the x-axis. That is the reference angle. In the next case, you see that we exceed 90, we're in quadrant 2, and we're at 113 degrees. That makes the reference angle the remaining angle here between the 113 and the 180. So if we take 180, subtract 113, we get the reference angle. The angle of 67 would be the one that could provide us the answers to the angle of 113. Here, 152, again, goes into quadrant 2. We would take 180, subtract 152 to find the 28. Notice reference angles are always between 0 and 90. In the next group, we exceed at 215. We are in quadrant number 3 now. And the reference angle is not the one formed here. We don't go 270 minus 215 because that would give us this angle. And that angle is not the one we're interested in. We would be interested in this one here, which is 215 minus the 180 gives us the angle that is formed with the x-axis. Same thing here, 248 minus the 180 gives me the reference angle. And then finally, we are in quadrant 4, which is what's left up to the 360, because that would form the x-axis. So 360 minus 310. All right. The next one is the same idea, but you have to do a little visualizing. And so let's do that. Here at 130, we're in quadrant 2. We would have gone past the 90 mark, and so 50 would be the reference angle for such an angle. At 250, we've gone past the 180 here, and so we have gone 70 past the 180. That's the reference angle, always formed between the terminal arm and the x-axis. Here at 188, we went 8 past, so 8 is our angle. Here at 315, we are 45 shy of this. Now, students are always like, when do I add or subtract? And I guess you just got to get used to that a little bit as to you're always forming it with the right, with the x-axis. Lots of students will want to take in this case, the 315 and subtract 270. They would get the angle formed with the y-axis, not with the x-axis. So be very careful about that. Here, again, 355 leaves us with 5 as the reference angle. 144 leaves us with 36 as the reference angle. Let's see here, why can't I drag it? Here we go. 215 leaves me with 35, and 260 leaves me with 80. All angles must be formed to be a reference angle with the x-axis. Now the next one is finding out values that match, basically provide you the same value, except maybe could be positive or negative. Now this is the whole meaning behind a reference angle. That if we have a reference angle of 45 degrees, there's that angle in the one quadrant. But that will happen in quadrant 2 and 3 and 4 at certain angles. And the trick is how to find those angles. 180 minus 45 will give you one of them. 180 plus 45 gives you the next one. And 360 minus 45 gives you the last one. The reason it does that is that, let's see if I can bring this out here for just a second. Basically what it does is it provides, let me just show all of these things. It provides the four triangles that exist. Let me get rid of all this extra stuff for just a minute here and just look at the four triangles here. What it creates are four triangles that all are the same, basically. They all have the same values, the same size, the same lengths of everything. They just happen to be in different quadrants. So your reference angle exists here, but then there'll be one that will be shy of 180. There'll be one that's just beyond 180, and there'll be one that's just shy of 360. That's where we get the this business here of the 180 minus theta, 180 plus theta, and 360 minus theta. Now these are not all exactly equal. They're equal in size, but not in their positive or negative nature. Some of these will be negatives, and some will be positives. But we're just trying to get you used to the idea of angle size, and then these would be the other ones in this case. Now, in the next question, we still want you to find a reference, or not a reference angle. We want you to find an angle that will produce the exact same answer as the one that's given. Now, to do that, you need to find the reference angle, and that reference angle will unlock all four of the angles. And you've got to find the other one that matches this one in terms of positive or negative. So the sine of 180, of 100, is just beyond 90, and so it's in that quadrant. Let me see if I can quick draw. Let's see here if I can do this. Let me just bring up something to draw on to talk to you about it. So if I was doing this, let's see here. So here we are. Sine of 100 puts me somewhere over here. So here's the sine of 100. Now what that means is 80 is my reference angle. Here is the reference angle. So I have 80 as one of my angles. I have 100 as one of my angles. If I wanted to have another one, I would add 80 to 180. That's 260 is another one. And if I wanted another one, I would subtract 80 from 360. What's that? That's 280. Now these happen to be the angles that would all produce the same triangle, one in each quadrant. Now in our case, we had the sine of 100. And that gave us a value. You can put that in your calculator. And it gave us a positive value. If we type in the sine of 260, we get the same answer, but it would be negative. And if we type in the sine of 280, we get the same answer, but negative. But if we type in the sine of 80, guess what we get? We get the same answer, but it's positive. This would be our answer. So in looking at what I did here, and we can let you kind of catch up to me, what I did is I found all of those angles. You can kind of see what I tried to do here. So let's have you kind of follow me through this. Oop, I don't know why I can't select here. There we go. So if I was doing this one of 240, I found out the reference angle was 60, and the other angles were 120, 240, and 300. And it was these two that had the same value. Here, the sine of 85 happens to be a reference angle, and so I found the other three angles, and the 95 was the one that was the same, and so on. We'll do some more of these in this next worksheet, but what I'm doing is I'm using one angle to get all four angles, and then I'm looking for the one that provides the exact same answer or value. I'll give you just a second to copy that down, I guess. Now there were two more things to do, which are kind of leading to today's lesson, is finding out when things are positive or negative. Now what you should find is you could pick any angle in quadrant 1, any angle, and type in sine of that angle, it'll be positive. Cosine of that angle, positive. Tangent of that angle, positive. If you pick any angle in quadrant 2, anything bigger than 90 but smaller than 180, you'll find out the sine value would give you positive nature numbers. Cosine and tangent would be negative. In quadrant 3, anything bigger than 180 and smaller than 270 will generate negative sine values, negative cosine values, but positive tangent values. Finally, in quadrant 4, you'd get a negative for sine, a positive for cosine, and a negative for tangent. Now in the new lesson, which will be a repeat of this lesson plus a little bit more, I will talk about a cool rule that kind of summarizes this, because it's very important to know when things are positive or negative. That would have helped us back here in this question, because if I knew that sine of 85 was positive, then I would know that if sine of 85 was positive, then the sine in this quadrant would also be positive. That would help me to find who's got the same exact answer as mine. The last thing we wanted you to do is type in the values, what we call the quadrantal values, 0, 90, 180, 270, 360. And you just type these in a calculator and it would provide you these values. What you're seeing is kind of the maxing and the minning values here. Let me bring up a little chart here. Let me go new here. And let me slide this over. What I want to show you here for sine is if I was graphing this. So here's our start. Here's 90, 180, 270, 360. What it says is sine starts at 0, and then it climbs to 1, if this is 1. And then at 180, it falls back to 0. Here it is. And then at 270, it falls to -1. This is down here at -1. And then it climbs its way back up to 0. And it will continue to do this. This is known as the sine curve. This is its graph. Now, if we were graphing cosine, which we'll do now, under the same conditions, watch what it's doing at these same times. It starts at 1. Cosine starts at 1. It drops to 0. Then from there, it drops to -1. And then it rises to 0. And then back up to 1. So this is what cosine looks like, very close to sine. They are kind of the same curve, but start at different points in time. Now tangent does a funny thing, but tangent is slope. So remember, it kind of rises and then becomes undefined. And so think of tangent as slopes, and that's why you get kind of goes from 0, no slope, all the way to a vertical line slope. So the last thing maybe just to cover here is what is a reference angle. By now, hopefully you know what it is. It's an angle between 0 and 90. It has to be in quadrant 1 basically, and what it does is it provides you knowledge about 3 other triangles that are positioned in the other quadrants. So that's going over the homework, and to be honest with you, because this is new and different, we'll do a very similar worksheet and just a little bit more information. So I'm going to do one more little video now on introducing the new stuff, and it'll feel like the old stuff still a little bit, just to make sure we get everybody on board. Okay?